Hello everyone, welcome to my CCI Enterprise course. In this course, you will learn all the technology related to your CCI Enterprise journey. And in case if you are looking for the actual lab type of scenario and the solution, then you can reach out. You can send me email Ratnesh721 Kumar721, that is here, and then I will send you that detailed info that how my students they are preparing for their actual lab training. It will be almost similar that what you will expect in the exam. You can practice. I will help you. I will guide you for 1 month to clear this exam. I will help you step by step how to drill down um, the solution, drill down the technology into small pieces, and I will help you to pass your exam in first attempt. So go for this course. This will be a good place where you can learn the technology. But if you are serious about the CCI lab exam, then you can drop me an email and you can get the detailed info. All right, so let me stop this video, and if you watch this video, you can simply contact me and you can get the information related to the new update that we have in the CCI Enterprise Lab. In 1.11, we have to understand about BGP troubleshooting. So what I have done that I have created one playlist related to BGP where we will go and understand each and everything related to BGP. First of all, the basics of BGP, how BGP forming, IBGP relationship, EBGP relationship, how BGP go and use the synchronization. So I have covered the theory, not only the theory, but you'll find that lab as well. So lab related to synchronization, lab related to IBGP, EBGP, lab related to route reflector, configuration, peer group, lab related to best path selections as well. So that means if you go and complete all these videos, so you can see number of videos 1, 2, 3, 4, 5, and 5 plus 5, 10 videos. So that means you will be very much good knowing BGP technology, and you will be very much good doing the troubleshooting as well, because in the lab section you'll find that I have done the path manipulation. So you want the traffic coming from this direction versus this direction. You are preferring ISP1 versus ISP2. What type of changes we can do, what type of attributes we can tune. So once we know the tunability, the changes, once we know that how BGP basic configuration happening, peer groups happening, etc., it's actually parallel that we can understand BGP design, we can understand BGP troubleshooting as well. So please complete these 10 videos, and these are going to cover our BGP section. So let's start. What is border gateway protocol? The first question arises is that already there are protocols, routing protocols. There is still why I need one extra protocol. Now the answer for this is that this is the exterior gateway protocol. Means this will override or this will run on top of any of the underlying protocol, any of the underlying IGP protocol, and it will work such as the application protocol. And that's true. If you see the port number that BGP is using, this is using TCP port number 179. Generally, applications they are using TCP port numbers, or they are using TCP or UDP. So BGP is a type of application protocol generally built to run over the over any of the protocol and cross the one or one autonomous system. Again, the autonomous system is one region, so cross one region and then it can go to multiple regions. Or if you want to control multiple region routing or the network advertisement or the routing control you want across the multiple region, then that's a protocol. Or in other words, we are telling that it's a protocol for internet. It's a highly robust protocol, and it has so many tuning options, it has so many attributes, so we can uh, tune it. And that's the thing. So it says advanced vector protocol with high level of tunability that can go across the regions. It is a type of application protocol. And the final point about this is that it can interact, or it can hold actually, it can hold a big amount of a routing database or routing table. Okay. Defined by the AS path, we know that autonomous system to autonomous system, it has its reachability. It is a distance vector protocol. It has the autonomous system number defined here. You can see from 1 to 65K. Few of the numbers are private and reserved. Nowadays, we have dotted notations as well for the BGP. Now, here you can see that why you want to use BGP. So when you have multiple connection exist to external autonomous system, means you have multiple exit, or you have multiple ISP connected with you. Either those multiple connections with the same carrier or provider but connect via routing policy. The existing routing equipment can handle the additional demands. So it is highly tunable. So if you want to do some sort of preference, path preference, some sort of load balancing, etc., etc., so those things are achievable with help of BGP tuning capabilities. Okay. Now, one very important point here is that BGP true benefit is to controlling how traffic enters the local AS, local autonomous system, rather than how traffic exit from it. So the true benefit is that how you are controlling the traffic when it is coming to you, when it is coming to local AS. Now we can have two type of neighbor. We can have IBGP, or we can have eBGP, exterior and interior BGP. IBGP means within the autonomous system. So in this diagram, router B, C, and D, they are IBGP peer, or they can be IBGP peer. And then different autonomous systems like AS 100, 200, 300, they can be eBGP, exterior BGP peers. Now we have options that what type of IBGP relationship I want. Do we have full mesh, or what other tuning options we have? We'll go and check later on that we have multiple options when we are talking about the internal neighbor relationship or interior neighbor relationship. Generally, when we are creating the IBGP relationship, we should create fully meshed. Otherwise, there are some other options to uh, do the advertisement for the network that one IBGP peer is getting and advertising to other devices. Now, one device can have only can be part of one autonomous system, and if you want to make part of multiple, it will throw an error. We have the AD value fixed for eBGP. For eBGP, the AD value, the administrative distance is 20, and for IBGP, it is 200. Okay, so that means the eBGP routes are preferred than IBGP routes. So 20 versus 200, lower is better. That thing we know. Now the BGP peer messages, we have BGP peer messages. What type of messages we have? So we have open message, we have keep alive, we have update and notification. Now open means that I want to form the relationship with my neighbor, and here you can see that an open message is sent between peer to initiate the session. The open message has several parameters like version, local AS, BGP router ID. Then you have the keep alive. Keep alive is something like you are sending the keep alive message to your neighbor that you are alive or not. In BGP, by default, it is sending that keep alive message after every 60 second. A 60 second into 3, that is 180 second, is the hold down timer. So after 3 keep alive message, if you are not getting response, that means your BGP neighbor is dead. You will mark this as a dead with help of notification message. So now this notification message is sent when there is a fatal error condition. If a notification message is sent, the BGP peer session is toned down or reset. Anyways, if your peer is down, that means you will send the notification peer is down. Then we have the update message. that are used to exchange the route between the peers. Now here in BGP state machine, that is the finite state machine, we have some other messages as well. So what exactly this is, that when a BGP peer session is forming, at that time, if you go, suppose if I have two routers and I want to form the BGP neighbor relationship in between that, so you will find that they will exchange some sort of messages. Those are idle, connect, active, open send, open confirm, established. Correct? So idle means that it is initiating the BGP state, then connect, that you are waiting for the remote peer, active, that you are actively initiating the connection. Obviously this connection is TCP. Then open sent. Open sent means you have sent the open message. Once you send the open message, then BGP listen for a reply, keep alive. So you have sent the message, you got the acknowledgement, that is open confirm, and then the finite state machine will establish the connection. Correct? So it's very easy. Idle, connect, active, open send, open confirm, and they establish. Now if peer is stuck in active state, the potential problem may be that maybe you have password mismatch, maybe ACL is blocking port number 179, maybe you have incorrect AX, maybe you have incorrect neighbor statement, and so on. So if it is stuck in the active state, that means it is not good. Correct? Then you have to troubleshoot and make this as a working. Now how we are going to configure it? We know that one router can be part of one BGP autonomous system. Go to the router BGP, and then the autonomous system. If it is a eBGP peer, remember, if it is a eBGP peer, they have the TTL value of 1. So they are always thinking that their next hop is, or their peer is one hop away. So in that case, you don't need to modify the TTL value. You don't need to modify anything, any other thing. Means router B of AS100 and router C of AS900, they have to give simple command, router BGP, neighbor and remote AS. That's it. Now, if it is a IBGP pair, then you can go and you want to update the source. So for example, generally we are using a loopback as a router ID. So in case of IBGP neighbor relationship, you need this update source loopback command, correct? And I'll come to that eBGP multi-hop option as well. Suppose if you have eBGP relationship and it is multiple hop away, then you can go and use the eBGP multi-hop. So for example, 200. So in this example, it is showing simply that suppose if you are using the loopback address instead of this physical address, if you are going to use the loopback address, that is again one hop away, then how you will form the relationship? So in that case, say for example, the router C is using the neighbor 1111, and we can see that who is 1111. Obviously this router B loopback address is 11111. So in that case, that will be hop away. For that we should go and use neighbor 111 eBGP multi hop 2. So you should count how many hops away your peer is, and then you can use this multi eBGP multi hop command. Finally, we can go and use the password with the neighbor command. So for that, we have the neighbor password, and so for example, Cisco. We have other option as well, that if you want to change the keep alive timer, we have discussed this about that the default keep alive is 60 seconds and 180 seconds is the hold down timer. But suppose if we want to use some aggressive timer, we can go and use timers BGP 30 and 90. And in that case, we can go and set the BGP timers. All right, so let's stop here, and in the next section we'll perform the lab whatever we have covered in this section. Now we have to perform the lab related to BGP. Here you can see in the diagram that I have router 1 in AS100. So AS100 and AS200 router and switch 105, they're going to form eBGP relationship, exterior BGP, and in between AS200, say for example switch 101 and 105, they are going to form iBGP relationship. Okay, so let's start the configuration for R1. If I go to R1, I can go and I can initiate the router BGP process. So for example, AS is 100. Then what is your neighbor? Now for neighbor, I can go and check the directly connected neighbor. So that is directly connected neighbor is this 10.1.1.1, 10.1.1.1.0.5. So he has the neighbor 10.1.1.1.1.0.5. And then what is the remote AS? So we should go and give the remote AS. Say for example 200 I'm going to configure. Then here if I go and check show IP BGP summary, you can see that state is idle, correct? So it has initiated, and if I go and do some debug IP BGP, what type of packets I want to debug. So for example, I don't want all, but if I can get events and monitor. So I can go here. Yeah, I can see some of the messages. So already we are monitoring over the screen. It's showing some of the events. If we debug IP BGP, just wanted to see the TCP number. So all address families and import in IPv4, keep alive, don't want that, out in, etc. Okay, if I do all, then it will be big output. Okay, now one other command we have. So here you can see that at least I'm getting this message, active went to active to idle. It's tried to move from idle to active, but it is not. And then here you can see that you have the TCB. So if we go and check show TCP, TCB, and then enter, show TCP, and if you want to see the brief, you just wanted to see the open ports if you have, and if you have any other option related to that. So you have the TCP TCB. Actually that's the command. TCP TCB is the command, and if you know the TCB address, that will work. Anyways, so let's move on and go to the other side. Here I want to initiate the router BGP process 200, and then the neighbor is a 10.1.1.1 whose remote AS is 100. That's it. So now if I go here and if we see the packet here, you can see, let's stop the screen. So here you can see that you have the open, capability is open, and then a route phrase, then open, again active, went to open, send to open, confirm. These exchange we have actually checked in our session, and then you can see the neighbor is up. And now if you go and check the TCP TCB, so now you're getting this established session, and you have the address as well. And let me do let me undebug. And now you can see the output for this. You can see the port number is this. So local port is this, the foreign port is this. Great. So most of the information we are getting from here. All right, so now the eBGP relationship is up and running. Now what I want that as per our diagram, I want to create iBGP relationship as well. So for that, I know that neighbor is say 101, 101, 101, 101, and whose remote AS is the same that I have. But since I am using the neighbor command, which is the loopback address, so I want to do the update source loopback 0, and I should check sure and interface loopback 0. So yeah, that's correct. Now I'll go to 101. So let's go there and let's do the configuration for this. First of all, let's enable the BGP 100 whose neighbor is 105, whose remote AS is the same that I have, and then the neighbor this update source loopback 0. Now if you go to 103, we go to 105, you will get one message, show IP BGP summary, that you have two neighbor, both are up and running. So one is up and running that you can see here. You have a 0 prefixes, straight is up and running. Now if everything is okay and correct, in between 105 and 101, so 101 and 105, then they should form the BGP, but it is not. So let's quickly check the BGP configurations, show run section BGP. So here you can see that I am part of 200, and this is also part of 200. So here you can see that directly you can see that problem, that we should have correct configuration. This is part of 200, and now you can see that we are getting some sort of uh, notification messages. We have seen that this is something when you have some error notification messages, we are getting some malform uh, construct. And if you go here and you check the summary neighbor idle, like that it is coming. Let's go back and let's change the AS and we'll come back to 10. All right, so let's complete the basic lab. Now here, if you go to 101, we can see that the BGP AS is wrong. So I will go and do the changes. We'll go and change this to 200, and then rest of the configurations are correct. All right, now once we done that, we can go and check the summary. You can see this is up and running. Likewise, if you go and check show IP BGP summary, that is up and running. All right, so now once we have this, what we can do, we can check other basic stuffs as well. Now, for example, that we are going to continue the lab, plus I'm going to add few topics more in the lab section. We'll go and check the BGP neighbors once we enable run the BGP. Then we'll go and check the BGP neighbor. Plus we have one concept related to BGP synchronization. What does it mean by BGP synchronization? Although our lab setup is different, but I'm going to take same type of structure, that I have one device for eBGP and few devices for iBGP, And then already we have checked the IBGP and EBGP, how we are going to form these BGP tables. Now what is happening that once we have the neighbor table, then it will build the BGP table, and then we have the routing table, correct? But one of the important table we have is the neighbor table. We have this command show IP BGP neighbor, where we can go and check the BGP neighbor details. If you want to check the specific detail to a specific neighbor, then you can go and use this command show IP BGP neighbor and the neighbor address. Next, we have the BGP synchronization rule. Now this is important. What is happening that the general rule for BGP, or the golden rule for BGP, is that if your BGP is there inside the autonomous system or within the autonomous system, so you should enable IBGP rule, or you should do IBGP full mesh capability inside the autonomous system. Suppose if you do not do like this, so what will happen? Say, for a example, in this diagram, uh, this AS wants to reach to this network. Now suppose if I have IBGP relationship here, so here I have obviously the EBGP, and here obviously we have the EBGP relationship. So the traffic or the update will come to B, and then B it can go to D, because remember, in BGP the IBGP neighbor relationship, it is not mandatory that they should have physical connectivity. So these BGP relationship can form over non-connected interfaces as well. Okay, so that means that I can have the IBGP relationship in between B and D. Now then it will go and reach to E. Now at this point of time, the router C, he don't know about this network 10505 etc. 10500. Next time if the return traffic will go and hit to D, and again suppose if it will go to C, since C is not having the update related to 10500, or he don't know how to reach to 10500, he will be working as a black hole. He will start black holing the traffic. So what is the rule then? Then the rule here is that you should have EBGP relationship, should have IBGP relationship in between all the devices, correct? And that's the rule you have. You should have this type of mesh rule or the topology, and that's the reason we are using uh, some sort of other technology like configuration or route reflection. Because say if you have so many devices within autonomous system, and if you go and turn on BGP, and if you do this full mesh IBGP relationship, then obviously the CPU, the core utilization, memory utilization will increase. So this is not the optimal design solution. This is not that all the routers could achieve this target, because obviously they have to think more, because they have more number of control packets to process. The same explanation here. What we can do for BGP synchronization, uh, the local AS is not a transit, so in which case you don't need, if your AS is transit, or all routers in the transit AS run IBGP and are fully meshed. Okay, so the question here is that when you don't need the synchronization rule, answer is when your AS is not working as a transit. Second, when you all the devices in the transit, they are running the IBGP rule. How you can disable the synchronization? The command is no synchronization, and you can see that 12.28T synchronization is disabled by default. So in latest code, the synchronization rule is disabled. All right. So let's just stop here, and we'll go back to our lab section, and whatever small and basic verification commands are there. First of all, we'll check that before moving further. Now we are going to perform the lab task. You can see in the diagram that we have AS100, we have AS200. Inside AS200, we have devices that are going to form the IBGP relationship, and in between AS100 and 200, we have the eBGP relationship. So let me quickly log into the devices. We are going to perform some of the tasks that we have covered already in the theoretical section. So let me quickly show you that what configuration I have over these devices, and obviously let's see the IP addresses as well over these devices. So if I send this script, you can see over switch 101 we have this IP. Let me show you this diagram as well. So here you can see the diagram and the IP schema. Router 1, that is inside AS100, having loopback 1111. All the switches, they have loopback as their name. So for example, here you can see the loopback IP, then the interface IP, then the interface IP. All right, so you can refer the diagram that we have, and as per our diagram, we have assigned the IP addresses to the interfaces. All right, now next thing that we should go and check the BGP neighbor. So I can go and check show IP BGP summary to all the devices. Now here I can see that as per our diagram, uh, we have eBGP relationship and the IBGP relationship. Now, if we have this type of topology, still what you want that switch 103 and 105, although they are not directly connected, they are indirectly connected, they should form the neighbor relationship. In that case only they have the full mesh, correct? So suppose even I have the back-to-back connection here, although I don't have, but still I can go and form the neighbor relationship in between the 103 and 105, because underlay we have EIGRP up and running. So before doing that, you can see here that all the devices, they have their eBGP and IBGP relationship running on. eBGP in between R1 and 105. So 105, one interface having eBGP relationship, other one is having IBGP. Now suppose if you want to know detail about that particular neighbor, so what we can do, we can go and check show IP BGP neighbor. And first of all, let's see that in this neighbor command, let me see that uh, what outputs you have. So you can go and simply check show IP BGP neighbor. Obviously it will show you all the neighbors. So here the neighbor ID is this, belonging to 100 as a autonomous system, the router ID, the establishment, what time the neighbor got established, what type of messages they have exchanged. Here you can see open, notification, update, keep alive, and route phrase. So like that we can get the details. Now if I am very much specific to a certain neighbor, then I can go and run the neighbor command related to that particular neighbor. So I have one neighbor 10.1.1.1, and I can run and I can verify that. Okay. So what I will do first of all, that I want to show you that we can form the IBGP relationship in between 105 and 103. So let's do that. I'm already inside 105. I can go here and router BGP 200. I have my neighbor, for example, 103, and whose remote is the same. And then for this neighbor, I can go and use update source loopback 0. Now again I will go to the 103 and we can run the same command. Then we have the neighbor, say 105, 105, 105, 105, and the remote AS is the same, and then the neighbor update source is loopback 0. Alright, so we can see here now show IP BGP summary that we have one new neighbor added. So not only my directly connected neighbor, but my indirectly connected uh, neighbor is also there. That's the true power we have with the BGP, because this is working as a overlay type of protocol. All right, so once we have all this information, then what I want, so I want to have a, so for example in router 1 and 105, if you go to router 105 and you want to put the password, suppose if I go to neighbor, say neighbor 10111, and you can give the password the Cisco. So if you put password from one side, other side also you should go and check the password, router BGP 100, and just to show you that it will take some time, because we know that keep alive is sending after every 60 seconds and the hold down timer is 180 seconds. So it will take some time to tear down the neighbor relationship. Still your neighbor is up and running, because BGP is meant to be slow protocol due to various reasons. So if you wait, it will take some time, because one side your neighbor having the password, other side we don't have the password. So I'll wait till the timer will expire, and then I can come back here and I can set the password. Meanwhile, we'll go and check the other option. So we have timer option as well. So for example, I can go here to the router process and then I can check the timers for BGP. Oops, timers, BGP, and then keep alive. I can give 30 and then hold down. Suppose if I 10 and 30, keep alive 10 and hold down if I give 30. That means for all the neighbors it is true. Now suppose if you are specific and you want to change the timer for a specific neighbor, so for example 105, 105, 105, 105, then also you can do that. So where we can go and check the timers here, you can see so many options we have. So for example 20 and 60. So it is telling that you should go and specify the keep alive, say for example 20, and the hold on is 60 as a peer group. So then it will take that command. uh, we can check later on about the peer group as well, so we can leave it, but yeah, we have option that we can go and specify over the uh, per neighbor as well. Okay, so let's quickly see this BGP configuration. So here I have the neighbor with some timer, and then if I go here and check, And we can go and check show IP BGP neighbor 10.1.1.1. So here you can see that we have the neighbor established time. It is showing that what is the hold timer and the keep alive. Although if you go here and check show IP BGP neighbor 105 and what is my neighbor, that is 10.1.1.105, and here you can see that still is this because maybe the command that we have run is okay. So here you can see the timers and the neighbor command. When we are running this neighbor command earlier, so let me show you that we are getting some error because that was not my neighbor. So that's the reason it was throwing an error, correct? Because my actual neighbor is uh, 10 11110 not 105.105.105. So what I'll do now, I can go here and I can do this neighbor and then 10.11.105 timers. I can specify say 10 and 30, and that's it. All right, we'll go here as well, and I can go here router BGP 200, neighbor is 10.111, timers are 10, 30, and then we can go and check show IP BGP summary, clear IP BGP say star. I'm clearing the BGP table, and now if we go and check the neighbor table, so let's go and check the summary. Now you can see that after clearing that, we have the authentication issue because we haven't put the password for one side, and here you can see the password issue is there. So I should go and show this neighbor and with the password. So I can go here and give the password as Cisco. Once I do that, you'll see that it will get converged and the neighbor will come back up. Now it is up. So we know that in BGP, first of all, it will form the neighbor table, then it will go and form the BGP table, then it will go and form the routing table, or those things will go and get added inside the routing table. Okay, so let's stop here, and next section we'll discuss more about all these behaviors. Next topic we have BGP route reflectors configuration and the peer group. Now what is happening in case of IBGP relationship is that whenever IBGP peers, they are getting the update from outside. So what they are doing, they are assuming that all the neighbors, either it is physically directly connected or it's not physically connected, they assume to be in full mesh. Now if they are in the full mesh, then all the IBGP neighbors will send the update to everyone. Otherwise, there are chances that, say for example, router D will get the update, he will send to A, but A will not send to the other router because he will think that update will come from some other way that is again connected in full mesh. Now, while we are doing the approach of IBGP full mesh behavior or approach, so in that case, what we are doing that we are using some more bandwidth. We are consuming actually more bandwidth, more processing and cycles. So why? Because we have more number of BGP neighbors, correct? So if you have more number of neighbors, more number of control packets will send and receive to maintain that BGP state or BGP neighbor tables, correct? So that's one of the thing that what we can do, that we can use route reflector. So the idea behind this is that any of the router which is there who is working as a symmetrical device. Now, what does it mean by symmetrical device? Symmetrical device means he is approachable or reachable to most of the other routers. So that particular device, we are making this as a route reflector. So when he get the update, now his responsibility is to give the update to all the other devices. And this approach actually has been taken inside software defined networking as well. How? So if you go and check software defined networking, you will find that we have clause architecture. We have leaf, spine, and leaf. And again, suppose if you have more spines, a spine 1 and a spine 2. So all the leaves are assumed to be connected with the spines. So what does it mean? It means that behind the scene, all these spines, they are working as a route reflector. So at the moment they are getting the update, now their responsibility to send the update to all the leaves. And that's the fundamental here in route reflector. At the moment he will get the update. So suppose if I make him as a route reflector, now his responsibility is to give the update to all the other IBGP neighbors. Rather than we have the full mesh topology, route reflector will reduce the number of code, reduce the number of IBGP pairs, will drastically increase the CPU and the memory performance. Correct? Now, not only the route reflector is the technique, we have other technique as well. We'll see in the next slide. So how you can do this? Here you can see I can go to router 1 and I can tell router 1 that your router B and D are the route reflector client. So the configuration is very easy. Just use neighbor, the route neighbor ID, remote AS, neighbor ID, route reflector client. That's it. Now we have other approach as well. We can use BGP configuration to come to the same place or to achieve same target. Although the configuration look like little bit tricky, but the concept behind this is to reduce the number of IBGP pair, and inside IBGP you can use EBGP type of behavior. So what is happening in this case, you can see in the diagram that you have main autonomous system. These main autonomous system, they will form the EBGP relationship. Inside this main autonomous system, I have sub autonomous system who is responsible, and you can think that who is child of the main autonomous system. So he is the child. But now since you have two different autonomous system, so 777 and 888, they will form EBGP type of relationship. So they will send and receive the updates because there is no problem with the EBGP relationship. We have this issue only with IBGP relationship. So inside the autonomous system, although it is showing only one device, but you may have multiple devices inside one AS. So they can exchange their neighbor tables, or they can exchange their updates within the across the autonomous system. Correct? So that's one concept, that you can see that you have different autonomous system inside same autonomous system. But what about AS500? When AS500 will see, he can see only AS300. He will not see the inside autonomous system, and that's the key here. Now the configuration is again straightforward, but it's like a little bit tricky. So first of all, this 888 is part of 300, 777 is part of again 300. Uh, so here you can see that router BGP configuration identifier this, then router configuration peer is this, then neighbor this, enable this. So you can see this configuration. If you go and check, you'll find that inside the configuration, you have to think that these are the eBGP peers, and inside that these devices can peer, but they are part of the main group, that is 300. So your 888 and 777, they are part of the identifier 300. Again, you can see that BGP configuration peer is 77. So for him, he is the peer. This is the configuration for router B. Likewise, if you go and do the configuration for router A, you have to follow the same step. So you can see that step number 1, step number 2, step number 3, and then this is the same one that we used to use, correct? And then finally, the remote AS that he has is the having the AS 500. Okay, so these are the steps that we should follow, and you can go and check all these steps. You can refer the diagram, and then you can have all these steps as well. So let me quickly go back and let me quickly show you that if you are here you can see router B is a part of eBGP. It's part of configuration group as well. So that's why you have this last line. Apart from that, you have these 4 lines. So it's tricky because see that he is part of main AS. He is doing the BGP with this AS, and he is doing the eBGP relationship. Now all these commands have been configured here, and you can understand all these steps. Now for outside device, the configuration will be straightforward, and what we have discussed earlier, neighbor and the remote AS, that's it. All right, so final topic for this session is the peer group. Why you want to use the peer group? Again, to increase the performance of BGP, to reduce the number of line, to reduce or to optimize the processor and the memory usage, you can use peer group. So suppose I have 10 different neighbors, and all those neighbors has 6 command that is common. So what commands will be common? So for example, remote AS, update source, route reflector client. These things are common. And I have 10, for example, I have 10 devices. So 10 into 3, that means 30 configurational lines you can put inside the peer group. So next, what you have to do, you don't have to write all these codes. Rather than you can go and use a neighbor 1111, for example, peer group, my group. Neighbor 2222, peer group, my group. That's it. Neighbor 333, that's it. So you are saving uh, a good amount of code, and apart from that, it is effective way to optimize the process and the CPU cycles. Okay. All right, so what I'm going to do in the next lab, that I will perform the task related to route reflector, and again we can go ahead and we can add the peer group as well. There are very less number of people that we know that they are using configuration. So, and even in this syllabus, it is not required that you do the lab or do the CLI configuration for configuration, but just for understanding purpose, I have given this notes and you can refer this. Okay, even in our CCNP course, it is not required to do the CLI configuration, at least for this section 3.2 for route reflector, but for future perspective to understand more about BGP and their coding and stuffs, we should understand the at least the route reflection and the peer group. Now we have the lab related to route reflector client and the peer group. Here you can see the topology diagram. We have R1 router and then switch 105, 101, 103. They are inside one AS. Already we have done the setup, like we have IGP as EIGRP running in AS200, and then we have eBGP relationship between AS200 and 100. So what I'll do here, that we have one loop back, you know that we have loopback here in AS100, and that loopback I will go and advertise. So for example, I can go to my BGP 100 and we have various methodology to advertise a network. One of the method is to use the network command and then give the exact mask. Now once we advertise this, I can go and verify this inside the peer router. So I can go and check show IP BGP, and here you can see that I am receiving this route. The next hop is 10.1.1.1.1. The AS path is 100. Now let's see if you check the diagram. So 111 loopback is coming to this device, this switch actually 105. Then let's see that how it is reaching to 101 and 103. So the same command show IP BGP, that's the BGP table. I can go and check to 101. 101 again, it is coming via this next hop. It will show like this only because eBGP next hop are not getting changed automatically. We have to run a command, so they will change the next hop. Now finally 103. Again, you can see that next hop is this. Now one thing I want to highlight here is that when you go and check the output in 105, you can see that you have the asterisk and the greater than sign. This asterisk means that it's a valid, and this greater than sign is best. So it's a valid best route that it is coming to 105. But if we go and check 101, so it is not telling that this is the best. Even if again further down the line, if you go to 103, it is telling that it's not the best route. That's the one thing. Second thing, that since we have created full mesh IBGP relationship, so if I go here and check show IP BGP summary, so we have the relationship with switch 105 as well. So what does it mean? If I go and check the BGP configuration, and if I go and remove this configuration, that is, I don't want the neighbor relationship form with the switch 105, and then obviously I should go and remove these subsequent lines. Now if we go and check the BGP, here it is. Now what I can do here, I can go and clear the BGP. Since this is the lab, so I can use IPBGP star, but be very careful if you're running this command. There are chances that thousands of route will get refreshed. So that's the reason we are using keyword like soft. So this is soft reconfig inbound and outbound, and inbound or outbound, like that we are using those keywords. All right. So now if I go and check show IP BGP summary, and we can see now that we have only one neighbor. And if we go and check the show IP BGP, that's the BGP table. So let me go and run that command show IP BGP. I want to check the BGP table. Now you can see this BGP table is gone. Why? Because that's the nature that the BGP has. So the routes coming to this, because they are directly eBGP peers, and then he will advertise to this. But 101 will not advertise those routes to the other devices. Okay, and that's a loop prevention mechanism we have inside BGP until unless they have in full mesh or route reflection or sub AS or this configuration. So now what we'll do, that will go ahead and make 101 as a route reflector. So let's go and do the configuration for 101. Alright, so we'll go here to 101. We are inside 101. I can go to router BGP 100. Then what neighbor we have? The AS is 200 for 101. So we have neighbor. Let's check the neighbor. We have this command. We can go and check. So I have 103 and 105 as my neighbors. So I can go to the neighbor, and then we can go and use as a route reflection client. So both for 103 and 105, I want to make this as a route reflection client. So 103 I have made it. Now if I go to 103 and if I go and check show IP BGP, still you can see that they are not learning the route that is coming from 105. So what I can do, that again I will go and make this neighbor as a route reflection client. And now if you go here to 103, that's the bottom one, you will start getting the update from router number 1. So it will be like it is coming from here, and then it will go here. Since he is the route reflector client, he will reflect the route to 103. And same is true. If the routes are coming in this direction, he is getting the routes, then he will go and reflect the routes to 105. So both ways you will find that it is valid. All right, so let's see this, because BGP updates, they are taking some time to get update. It's taking some time. Let me quickly see this. Do I have the relationship with 101? It's there. I'll go and do clear IP BGP star. Now it is showing idle because now it is up. So I have my table that is up. Now I told you one important thing, that whenever we are getting the routes, what is happening in case of IBGP. So you got the route, you know who's the next hop. He got the route, and his next hop should be this device, correct? From where I am getting the route. But if you see it, you will find that the next hop is still 10.1.1.1.1. That's the problem we have with the uh, IBGP relationship. So what we can do here, we can go to 101 and we can make, say, neighbor. So who is his neighbor? Say 103. So neighbor, before doing that, let me quickly show you this if all the BGP configuration is correct. It's correct. So I can go to neighbor. Hey, this is the neighbor, and you know your next hop is me. Okay, and likewise this router, I can tell router BGP 200 neighbor 101, your next hop is me. So this guy, your next hop is me. Now if you do this thing, if you go to 101 and if you check show IP BGP, you will see that first of all I need the best route here. Okay, so here you can see that 105, he is telling 101 that next hop is me, hey neighbor, this is my neighbor. Your next hop is me. So that means if you go here and check, this should change. See, it's got changed. It took some time, but it got changed. Now if you go 103, you are getting the updates. Even we don't need this command here to 101. If I go to 101 and if I remove this command 200, that is no neighbor 103. I'm your next hop self. Before pressing enter, if you go here to 103, who is the next hop it is showing? It is showing that its next hop is 105. That's okay for this point of time. So I can go to 101 and I can delete this. We can clear the routes as well, but ultimately we can see here that the target is achieved. So without having IBGP relationship, with help of route reflector client, 103 is able to get the routes from the EBGP from other AS whose actual AS is 100. Great. Now the second thing that we have to do is to do the configuration related to BGP peer group. So if you go again and check the configuration, although I have one command, I have two commands, very less lines of configuration I have here. But if I go to 103 and sorry, if I go to 101 and 105, so if I go here show run section BGP, I have more number of configurations, so that I can reduce. So how we can do? We can create the peer group. I can go to 200. I can make neighbor, and then you can see the name of the peer group. Say BGP peer group BPG. That's just the name. Then what I can do here, that I can go and give the peer group. That's it. Now next, what we can do, say neighbor BPG, and what's the remote? Say remote AS 200. Actually, I'm making this just for the IBGP relationship, so that's why I'm using this. Then again, I can go to neighbor BPG, update source loopback 0. Then again, I can go and check the other commands. So let me quickly go and check show run section BGP. So I have taken this command. I have taken update source loopback command. Then I have one more command, that is route reflector client. So for that also I can use it. So neighbor m say BPG and then route reflector client. Alright, so once we have these commands, obviously I'll go ahead and I will remove these configuration. This is not required now. So once I have these, then I can do neighbor, say this, and peer group is BPG, then neighbor, say 105, and the peer group is BPG, correct? And if we go and check the oops, sorry for that, if we go and check the configuration, where we are, I think I lose this. run section BGP. All right. So here you can see that now I have the peer group, and then neighbors are mapped with the peer group. Correct? Even I don't need this command. Say I should remove this, is not required, taken care by peer group, and this is not required, taken care by peer group. Now think that suppose if you have more number of IBGP table or relationship, still what will increase? Only this line, correct? So now you have template where at least your 3 configuration lines are constant. That will be recalled by all these peer groups, correct? So now what I can do, I can go ahead and check show run section BGP, and I have an IBGP command. So what I can do here that I can copy and paste. So for example, these 4 lines here, and then my neighbor is this 103. Actually I don't want because we have removed that, and this peer group is a PPG. But suppose if you have more number of uh, peers or the neighbors, then you can go and do these commands, correct? Then obviously I can go and do no for this, and finally no for the neighbor command that we have with 101. We can go and check show run section BGP. We can go and check show IP BGP summary. Seems one is gone. Show run section BGP. So here you can see that I should have that neighbor command that is not showing here. So finally what I can do, I can go to neighbor, say 101, 101, 101, 101, and then the peer group is say BPG, and we can check to show run section BPG, that is BGP. Alright, so here you can see that you have the template, and then you're calling that template with this command, and our BGP is up and running. So this is the way that we can do the peer group. This is the way that we can go and do the configuration for the route reflector as well. Hi there, thanks for your enrollment. We are in 1-minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy, and if you're going to enroll my courses, you will get 95% discount. Every month, 3 times, first week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount, up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, Ccie Ei Data Center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. We have very important topic, BGP best path selection. We know that BGP has a long list of attribute, and with help of these attributes, BGP used to uh, provide best path. So what are those? Let's understand those first, and then next we have series of lab, and we'll test all these attributes, at least the important path selection attributes in the lab section. So how BGP providing the best path selection criteria? BGP contains multiple routes to the same destination. It compares the routes in pair, starting with the newest entry and working towards the oldest. Now, if you see that how it is going to determine, so suppose if I have uh, multiple paths to reach a certain destination, and then I'm going to check, means BGP is going to check criteria A, B, C, D, etc. in order to provide, okay, if this criteria, so I have to go via this path. If this criteria, I have to use this. If this criteria, I have to use this, like that. So this is in the order. First of all, it will go and check the highest weight. Then it will go and check the highest local preference. Now the weight and local preference we'll see in the lab section as well. We have following lab with that. You'll find that weight and local preference, at least local preference, is one of the attribute that is mostly used. Now both the weight and local preference, they are dictating the best outbound path. So what we are doing, we are applying the weight and local preference, um, say attribute values or these values in the inward direction. So we are going to apply to the inward direction. That's the key actually. So where you're going to apply these and to whom he is going to affect. So we are going to apply in the inward direction, inbound, and then they are going to dictate the outbound path. So that's the important thing that I want to cover. Now here you can see the order. So let me go back. Weight, local preference, locally originated route. We know that if it's local originated route, their next hop will be 0000. That means it's the self-originated route. Then the AS path. Now AS path and MED, the metric value, both are again important. So remember, weight plus local preference, both are very much similar. Then AS path and MED. These are the attributes that is used more and more in the production network. So AS path, we know that BGP is dealing with, or BGP is a distance vector protocol. And as per the AS, so you think that one autonomous system has a router for a point, for a moment. And then if you have to cross more number of AS or more number of hops or router, that means it is not preferred. So if I am reaching to certain destination with 3 AS versus 1 AS, that means that 1 AS means via the path I am reaching with 1 AS, that will be the preferred. So shorter AS will be preferred. Then the origin code in the number, so IGP over E, GP over unknown. Then MED, again I told you that this AS path and lowest MED, both are very much similar, and even we have lab as well for these. Then BGP route type, eBGP over iBGP. eBGP will win. Then the age of the route, who is the oldest is preferred. Then the router ID, who has the lowest BGP router ID. Then the peer address, which router originate from the router with the lowest IP. So everywhere you will see that except weight and local preference where the criteria is high. Apart from that, AS, MED, then age, everything is lowest or the oldest. correct? All right, so here you can see that weight and local preference are applied inbound, dictating the outbound. That's the key actually. So these 3 4 lines are the key. Inbound dictating outbound path, and AS and mid are applied outbound, dictating inbound. So what does it mean? So at least in case of MED, and let me draw here. So suppose you have ISP1, ISP2, and then you have your local AS. Now in case of MED and AS path, if you want to prefer ISP1 versus ISP2, so then you will go and apply the either MED or the AS path, AS prepend. That's the key, because you have to choose, because you are choosing the outbound, so you have one subnet XXXX and you want to prefer either ISP1 or 2, you can use this method. Now when we are going to use the local path, so in that case, say when you are going to dictate the outbound path, so suppose if you have two exit and you want to choose one exit via versus second exit, so that in that case you are going to apply the either weight or local preference. Obviously I'll go and clarify these terms in the upcoming lab, and we are going to check the scenarios as well. So here you can see that you have one situation, one scenario, that you have one route, say for example 192.1.1.0, that router D is also getting, router B is also getting. Now what I want, that I want that the route should come or should preferred via router B. So in that case what we can do, that we can go to router A, say router A, and then we can give neighbor and then the wait command. That's the one way. The other way, nice way, is that we can go and use the route map. So then what we can do, we can create one ACL or prefix list or access list, and then we can create the route map. We can match the prefix list, and then we can set the weight, and then we can go and apply to the neighbor. So here you can see the direction. Direction is in for the outbound traffic, correct? So to reach this network, I have applied weight to my neighbor, and that neighbor, so that means router A will prefer B to get these routes, correct? Again, you have the local preference. In local preference, the same thing, only the way that we are going to do the coding will change. And here you can see that um, we are going to apply now. Local preference has little bit difference with weight. What is that difference? So unlike weight attribute, local preference is passed on to IBGP peers and sending updates. Local preference inform IBGP router how to exit the ACE if multiple path exist. So now what we can do, that local preference, even I can go and apply to these guys. So suppose local preference here, if I put 200, and if I put local preference 100 here, obviously this path will be preferred, correct? So that's the use of local preference. And here you can see that we have the example, but here we'll check the route map way of applying the local preference. Again, you can see here the direction is inbound, so here we are at router D or maybe at router B also, there's no problem. So what we are doing for router B and D, here you can see that B and D, lower is better. So here, if B is 200 and D is 300, obviously the traffic will come via this B, because his local preference is 200. Likewise, you can see here in the policy, we can create the policy for B and D as well in the upcoming lab section. So I have this route, Same way we have created the route map and we have applied it. I'm matching this and then I'm setting the local preference as so for example 300. Okay, and then I'm applying in. So here you can see that is 1.2, that's my neighbor. Then I'm applying in. Likewise I will apply with local preference of 200 to router B. So obviously router B will prefer. Okay, so here you can see there's difference between wait and local preference. The local preference is passed on IBGP peers when sending the update. So that's actually the main reason you will not find use of wait more and more, because anyway the wait is Cisco proprietary as well. So mostly you will find the use case with local preference. The same thing we can do with wait with local preference, so better use local preference. And in the lab section, so we have the lab section. In the upcoming session I will go and perform this task of wait and then local preference, and we'll see that how we are applying the in rule to affect the outbound traffic. Correct. All right, so let's stop here. We'll start the lab now. Let us perform the lab task. In the lab, what we are going to do, first of all, I'm going to show you the entire setup that we have. Here you can see that we have 4 different autonomous systems, say AS50, then AS100, AS900, and AS200. Now from AS200, you can see the iOS, the router is router 7, for example. There I have one loopback, and that loopback is loopback 7777. 7.7.7.7, and that particular network I'm advertising with BGP network command. So they will go and reach to AS 900, and then it will go and reach to AS 100. Inside AS 100 it will go and reach to router number 2. So before showing a complete path and how it is reaching, let me quickly go and show you the uh, configuration that we have. So if I go here and check the configuration, show run section BGP, here you can see the configuration, and these IPs that you're seeing over the interface, these IP addresses you can refer the topology diagram as well. So router 1, here you can see the router 1 has very minimum configuration. It has one interface, and then we are advertising one of the network. Then router number 2, you can see the BGP configuration where we are running EIGRP inside the AS, and then we have 2 neighbor peer command, router 3 and router 4, and obviously we have one eBGP with router 1. Likewise, the configuration, BGP configuration for router 3. So let me do this. So here you can see the configuration for router 3. Router 3 in the diagram, you can see that it has eBGP relationship as well. So on the top you can see eBGP relationship with AS900. Likewise, we have router 4 configuration for BGP. Then we have BGP configuration for router 5, and then you can see router 6 and 7 as well. This is router 6 configuration, and finally router 7. Now what we have done, you can see that inside router 7 we are advertising one of the loopback with the BGP network command, and then we are going and seeing that how it is reaching to router number 2. So if I go and check show IP BGP, first of all I'll show the BGP table. So clearly you can see this AS is getting prepended. So the originator for that is AS200. So here you can see this 777. So the originator, then next is 900, and then it is reaching to AS 100. Now here you can see that you have valid and best path, and who is the valid and best path? So it is telling 172.17. Now if you go here and check 172.17, so this is the best path. Via this it is going and reaching here, although you have the alternate path as well, that is 172.16. So 172.16, that's only the star we have, and the star means valid. So that means if I go and check show IP route for this particular network, and let's see. So here you can see that it is coming via 172.171.2, and they have learned this is the router tag and how many hops, etc. Correct. So it is learning via this. So what I want at this point of time, that it should go and learn via this particular neighbor, not via this neighbor. Other thing that we can see here, that is this changing the next hop? So if I go here and check the diagram, so obviously whenever it will go and move to the eBGP, then it will change the next hop, correct? So from here, either from router 3 or router 4, it will go and reach to router number 2. But suppose behind router 2 you have one other router in the same AS, so at that point of time you can see some differences. So you have to do some next hop self command, correct? So suppose if I go to router number 1, and if I check show IP BGP, now since this is the eBGP relationship, so for this route, who is the next hop? So he is saying that his next hop is changing, that's okay. But if router 1 will be also inside AS 100, then it will be the problem. Anyway, so what is our target here? We want to have, or we want to learn this particular route from this next hop, or from this peer. So let's use the wait attribute. Before that, I want to create IP prefix list. So IP prefix list, say loopback 777 is the name of my network. Even I can go and give the uh, sequence number, and then I can use this if I want. So sequence 10, and then permit 7777/32. All right, then I'll go and create one route map. Say my wait permit 10. What I want here, I want to match. So let's see, match the, let's see what is the option we have. So match the IP address, and that is the prefix list. What is the prefix list we have created? This loop 777. All right. Now what I want to do with this, I want to set, what I want to set the wait, say for example 8989. Then I will give one default statement for route map where I will not match anything, say for example 100. We can go and check the route map configuration. Say route map. So what we have done, that we created one IP prefix list. We have matched with the route map. Then we have set the width for that. Now we should go and apply this to the neighbor. And which neighbor you want to apply? So you want to apply this with 172.161 dot, oh, sorry, we want to apply with this neighbor, that is 10.1.1.2. So I'll go and apply with say 10.1.1.2. And what's the route map we have? The route map name is my TT. Because this is weight, so I want to apply in the in direction. So here you can see that it is telling that okay, so this is not the configuration that we have done. If you go and check, we have created the neighbor with the loopback, correct? So we should apply with the loopback statement. So here you can see, so I should go neighbor, and the neighbor is router number 4, that is 444, and then the route map, and that will be in the my weight in the in direction. All right, now if you go and check show IP BGP, now clearly you can see that uh, the next hop is not get changed. So for example, that's a problem actually with iBGP, and that's just to prevent from the loop. So that's a loop prevention mechanism. So what does it mean? That here you can see when the routes are coming, say 77777, and when it is entering to this AS, they are putting their uh, IP as a next hop. When it reaches here, it should put these IPs as a next hop first of all, correct? So we should go and do a small changes in the configuration. So let me go and do the small change in the configuration. So let's do this. I can go to router number 3, say router BGP 100. I can tell neighbor 222222222, next hop self, and likewise we can go to router number 4 as well, and then we can tell router BGP 100, neighbor is next hop self. Now if you go here and check show IP BGP, you will see that next hop will get changed. Otherwise I'll force this BGP to converge. Here you can see at least next hop is not get changed, but the priority, I can see that wait update has been done and it is going via the uh, bottom router. So here you can see that wait has done his effect, but it should change the next hop as well. And now you can see that they have changed the next hop. That's the correct actually. Wait has been changed, next hop has been changed. So this is the way, this is the use case with the wait. Now what we want here, that instead of wait, the same thing I want to do with the local preference. So first of all, I'll go to router BGP 100 and I'll remove this command. I don't want this wait, for example. So we don't need this wait. And next, what we want, that we want to use the local preference. So for local preference, let's go and check the route map as well. Route map, because now for local preference I want to create one route map as well. Now this time I don't want to apply this policy to R2. Rather than I want to apply this policy to R3 and R4. So how the local preference is working, that they are much more intuitive than wait, and their attributes can flow inside the AS. That's the key we have. So what we can do here, first of all, we'll see that how the 777 is getting reached to router number 2. Then here over router 3, I will set the local preference as 300, and router number 4, I'll set the local preference as 150, because I want that it should go and prefer this direction. Or suppose what we can do that I'll go and create one more network here. So for example, 88888 as well. Already we have 7777. I'll create one more 8888. So 77777, for example, should go in this direction, and 888888 should go in this direction. So how we can do that? Okay, so let's think that and let's try to perform that task. All right, so the target here is that 7 should go via router 3 and 8888 should go via router 4. So primary, secondary, primary, like that. So what I try to explain here, let me go and show you here. First of all, I go to router number 7 and I'll create one more loop back and I'll advertise that as well. So I can go here and create say loopback 8, IP address 88888, and then let's go to router BGP 200, and then we have the network 888 with the mask of 255. Now if I go here and check this same BGP route here, so now you can see that 8 is also coming and getting here. Now it is coming 3 and 3. So both the update, they are coming via router 3 that we don't want. For 7, say for example, I want that it should come via router 3, backup will be router 4, but 8 should come via 4 and 3. Okay, so primary, secondary, and secondary, primary, like that we want to use. What we can do here, that we can go to now to router number 3 and we can create the prefix list first. So I'll go and create IP prefix list, say loop 7777, sequence say 10, permit 777732, and then I want to create one more loop back, because the deterministic criteria, I want to put some condition inside the route map. So I can go and create the network statements like this. Okay, so I have two different IP prefix list, and even I can copy and paste the same configuration to 4 as well, just to save our bandwidth. Alright, so once we are here, then we should go and create the route map. Say local pref, what I want to this route map. Say permit 10, match IP address, and that is the prefix list 777. For this, I want to set the local preference, say for example 8888. Okay, then I'll go to the other statement, that is say for example 20, and then I'll go and match the address, that is this guy here, and then I want to set the local preference a little less. So for example 88. Okay, and then I have another default route map like this. All right, so here you can see the strategy for 777. We have the higher local preference. Likewise, I'll go and I'll create one more route map here to router number 4, where I want to match the 888. So statement number 1, I'll go and match the IP address, that is 888, and then I'll set the local preference, say for example 9999, that is very high, and then I can go to the other statement where I want to match the address, that is this guy, and then I can set the local preference 99. So the idea behind this is that for one of the prefix list, say for example for 888, what is the local preference? Very high. And here for 888, what is the local preference? Very low. So just the condition. For 7 we have high, for 777 we have high local preference, for 8888 we have low local preference, here the reverse. Correct? Now we should go and apply this to the neighbor. So let me see that who is the neighbor. It's the neighbor IP, router BGP 100. My neighbor is this guy here, and then the route map is local preference in direction. Correct? Now here also I can go and check router BGP 100. My neighbor is this guy, and the route map that we are going to use is the local pref is the name, and then the inward direction. All right, now if I go here, so for 888 the 4444 should be the best path. So here you can see, now we can see clearly that they are losing the backup. So here you can see that now the routes are converging and they are getting set with the correct local preference. But still, if you want to clear the IP BGP star, you can go and do that, and then you can go and check show IP BGP. So it will take some time, but it will build the route, and clearly whatever our target was, we are able to achieve that target. Correct? So this is the way that we can go and apply the local preference. Hello everyone, I'm going to give you offer related to Ccie Ei lab. In this lab, what you will find, so let me quickly show you that. In this lab, you have multiples switches. You can see you have more than 16 switches, 20 routers. You have a SDWAN full-fledged lab. Actually, this is complete Ccie Ei Enterprise 1.0 lab, where you can do section 1, section 2, section 3. Maybe you know that in Ccie Ei exam, you have 3 different sections. Means already sections are defined, but generally these 3 sections that students are practicing. And in this 3 sections, you can perform everything, all the tasks you can perform in this particular EVE-NG lab. You can see the version and the supported images. This is exact match that we have in the exam as well. So for example, for SDWAN, you need to work on V edges and the we manage, release is 18.4. That's the same release we have in the exam as well. So this will be your very much similar lab setup that you have in your CCI exam for your practice purpose. Now, what you can't do in this lab, you can't do lab related to DNA because in this EVE-NG lab, we don't have Cisco DNAC integration, and you can't do ICE lab as well because in this we don't have ICE integration as well. For that practice, you need full-fledged online rake from any good place. You can go and have it. But apart from that, apart from 2.1, 2.2, actually, you can go and perform all the tasks. Even if you are not practicing for your CCI exam, for example, you are practicing for your CCNP and you want to check your OSPF knowledge, BGP knowledge, MPLS knowledge, SD-WAN knowledge, all those tasks you can go and perform in this lab. With this lab, I'm providing the video guide, how to do all those tasks. Even we have the lab guide as well. So you can simply follow those guide. You can simply go and complete all those tasks. Suppose if you are new to the technology, so I have multiple free videos in YouTube and Udemy that you can go and refer to upskill your knowledge, to learn the technology, and then simply you can go and use this particular lab and you can break any CCNP, CCI exam. Means you will pass it easily. Now, what is the cost? And these are the sections that we have in the CCI exam. So what is the cost of this? Because I'm offering this for the students, so I put very little, a small cost here. So you have to pay only 150 USD to get this particular software. And how you can go and get it, you have to email me. So my email address, you can send me one email request. Let me write here, Ratnesh721 Kumar 721 @gmail.com. Just email me and send me the request, and I will give you this particular nice software, full-fledged software, EVE-NG software, or the file where you can go and practice your CCNA, CCNP, CCI, SD-WAN, full-fledged SD-WAN is there. So if you can go and watch my YouTube videos, in YouTube I have 22 hours SD-WAN video recording file and so many SD-WAN videos I have uploaded in YouTube. Those YouTube videos also you need some lab setup, right, to practice. So even if you're not preparing for your CCNP or CCI, simply you want to learn Cisco SD-WAN, you can go watch my free videos in YouTube, use this particular lab setup, and you can perform your SD-WAN. You can become master in the SD-WAN. Likewise, if you're preparing for CCNP, and CCNP, again, we know that we have N core and one elective. For that also, you can go and perform all the tasks related to routing and switching, OSPF, BGP, everything in this lab. It's a full-fledged lab. So I will recommend you to send this email right away. Take this particular lab, practice, enhance your skill, and become very good in the market so you will get high paid salaries. All right. After that, you go and watch the technology video. Thanks for watching. Thanks everyone for enrolling this course. In this course, you will learn all the technologies related to CCI Enterprise. But in case you are looking and you are preparing for your lab exam, please feel free to contact. We are running some sort of 100% guarantee program to make you pass. I will provide you the lab, resources, everything. If you want to know more about this offer, you can go and email to this particular address. Anyways, in this course, you are going to learn all the technologies. This will be very useful course to you. But in case you are planning to write your lab exam, just feel free to contact us. We'll provide you all the guidance, all lab related tips, techniques, all the passing techniques, etc. So please do not hesitate. Feel free to contact us and we will provide you and we will assure you that you pass your lab exam in first attempt. Thank you. Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best.